If you're interested by the sine wave who's getting out of this device, you can be interested by the fact that I struggle a lot to capture something like this because the signal was so low that I had a lot of problem, but I managed to make something special to capture this waveform. Actually, you can see here on the output, this is a ceramic capacitor, and it's working like a resonating circuit with the self inside this device, which produce a higher voltage, easier to see with the scope, and this is what we have here. So actually it's very difficult to measure this kind of thing because, as you can see, it's very noisy. I make the experiment to use a classical cable like this, and also the dedicated cable with multiplied by one probe like this one. And of course, on the classical cable, you will have those noise, and the waveform with the probe, you have a more cleaner signal. Of course, I had to put some inductor on the line. There is one here and here to reduce the noise, because the noise was actually very high. And of course, I switched on the filter on the scope to see something more clearer. And as you can see here, because this clearance, the signal is more neat now. You can see something like 16 kilohertz, which is logically dedicated for this, because here you can see the cursor, and the cursor, when you adjust from the beginning of the waveform to another beginning, you will see here a value of 60 microseconds, which is actually what we found on the scope, nearly what we found on the scope, 16 kilohertz. So we can understand that this device is not working with 100 kilohertz, but with 16 kilohertz, and apparently it's perfectly enough to make the stuff working. It was Alexander again. I hope you like this video, and till you see you soon.